All right, so today we'll be talking about how blood types affect COVID-19 and how ill or how sick you can be depending on your blood type. So the name of the article was the ABO blood group locus and a chromosome gene cluster associated with SARS-CoV-2 respiratory failure in Italian Spanish genome wide association analysis. And the title of the news story was How Genes May Leave Some People More Vulnerable to Severe COVID-19. And my name is Bahadin Abdulrahman, but I go by Baha. And the class this is for Bio 182 Lab. And the TA's name is, hopefully I don't butcher her name, but it's Darakshan Zebin. So some background info and introduction to the study. Respiratory failure is a key feature of severe COVID-19 and a critical driver of mortality, but for reasons poorly defined, affects less than 10% of SARS-CoV infected patients, which means that if you had trouble breathing prior to having COVID-19, it will increase the risk of you being more severely ill and perhaps maybe dying. So severe acute respiratory syndrome coronavirus, which is also called SARS-CoV-2, it was discovered in Wuhan in China in late 2019, rapidly evolved into a global pandemic. So it really was in late 2019, and the actual reason for it is not clear yet. I tried looking it up, but it wasn't clear yet. Like some people say it was from the lab, and then I'm not sure, but it's not too determined. And it was rapidly evolved into a global pandemic. As of May 28th, 2020, there were over 5.1 million confirmed cases worldwide. And a lot of those places that were really infected were Wuhan, China, of course, because that's where the disease came from, or the disease or the virus came from. And then a lot of countries in Europe, which is where the study takes place, in Italy, Spain, and so on. And coronavirus disease 2019 has a variable behavior, with most infected individuals experiencing only mild or even no symptoms. So materials and methods. Material methods in the study, 1980 patients, or 1,980 patients with COVID-19 that had respiratory failure. We're at 7 centers in the Italian and Spanish epicenters, because that's where it was really bad. Also in Italy and Spain, halfway through. So in 2020. And so where specifically in Europe, it was in Milan, Monza, Madrid, San Sebastian, and Barcelona. And what did they do with those 1980 patients? They were included for a genome-wide association analysis to determine what affected people's respiratory failure. So what were the results? The results were a bunch of different cross-replicating associations. So they ended up with different chromosomes. One of them was the RS11385942, and then the other one was 3P21.31 and RS651752. And all of these are different chromosomes, and these chromosomes, they affect your blood type, and they play a role in your blood type. And depending on your blood type, they determine that blood type A was, if you had blood type A, then you're at 50% more risk of having issues or respiratory failure if you had COVID-19. So in conclusion, it was reported that the first robust genetic susceptibility loci for the development of respiratory failure in COVID-19 was determined, and identified variants may help guide targeted exploration of COVID-19 pathophysiology. So basically, after this study was done, it helped people learn more about COVID-19 and what it did or how it affected people. So how does the article relate to what we learned in lecture? So this article relates to what we learned in lecture, since it talks about the genome, which is the gene. And the gene, as we said before, it plays a huge role in the genotype and phenotype. And the genotype is, as we said, or as we learned in class, genotype is the genetics So whereas the phenotype is the physical traits. So the genotype is, in this case, in the study, is your blood type, whereas the phenotype is how sick or ill you'll be depending on your gene. So people with blood type A were seen to be sicker or a lot more sick, which supports that their genotype had more recessive alleles than dominant and therefore became more susceptible to disease. And here are the references. And yeah, thank you guys for listening.